I need to put in the signage, but we'll do that at the end. Yeah, so this is kind of like the whole digital world and like a glimpse of all the majors you're going to be in. Electrical engineer, you go like really deep into the electronics of it, and then the computer engineer starts putting up the computer parts, and once you get to computer science, you're building the applications, and information technology, you're using the applications. Then at the end, you come to either the choice of being a security professional or a hacker. Of course, nobody's gonna have like that in mind. You would probably, if you came to this, you'd know that this is ECE, CS, and IT. We're going to talk about those three majors. So, and not those three majors, actually 5. And so let's begin. What makes? Oh wow, this doesn't have a far range. Okay.
Doesn't have any.
Well, yeah, it does have about this range. Okay, so the reasons for choosing a major. So worldwide, lots of people would go with to get a higher or more stable income because it's because that's basically what most of these high-end majors are. Otherwise, you'd just be working as an undergrad. Would save you a lot more money than coming to university for 4 years, as well as save you a lot of time. The second reason why people would choose a major would be they find some major, some subject that's interesting to them. So that's why they go on and learn more about stuff rather than start going into a company. So, and then the third reason why people would choose a major would because they have a natural talent for it. Yeah, so just because they find it so easy, they can just coast along, and it's much better than having to have a troubling job from 9 to 5. And then the fourth one usually occurs in Asia, is parental or communal pressure. Basically, your parents are trying to get you to get a really good job in the future and have like a sustainable family stuff. So and some people just get forced into choosing their major because of their parents. Sometimes their parents don't like some of the decisions they made. Like I wanted to, when I was 11 or 12, I wanted to become a computer game maker, like game programmer. And my dad was like, "What? You're gonna live in a trash can all your life?" Because basically you're just gonna be doing a small task that can be easily outsourced to much of India and China. There's a lot of programmers there, but. And the fifth reason I like this because like almost like many people won't tell you that's the reason, but I guarantee you there's some people when I go out to some of the social events, they're gonna, after a few drinks or something, they're gonna start saying, you know, I'm gonna plan this big, I've got this big scheme going to start ruling the world. And that kind of falls in line with all the comic books and all the superhero movies, stuff like that, where here are some of imagine these guys, they get their doctorates and I don't know what their dissertations were, but they're always evil at the end. The superheroes are like students or, you know, high school kids, but then all the ones that get doctorate degrees, they always turn out to be evil. And then, so probably you'd want to be one of them. So, I don't know. So that's probably one of the things. Now let's go on to what the types of majors that Mason allows. Here's the first one, is electrical engineering. We build the digital world from an analog world. We basically work on circuits. That's our main focus. I'm an electrical engineering bachelor's, and to tell you the truth, you're going to be working a lot of hands-on things with like an oscilloscope, with a multimeter, and you're going to be soldering things into small, tiny little chips. You're going to usually use one of those bifocal lenses or something to like zoom into those micro or nano parts we're going to be using. And some of the software we use, MATLAB for signal processing, our image processing, I didn't put that in there. But yeah, so basically to detect, just to run math code, math equations simulating what a signal would be. And you can even feed it out into a robotic arm or a pulse width modulation to any motors. And so you can connect devices to your computers and run MATLAB code that can simulate those devices, that can control those devices. The second one is active HDL. I was going to show you something that I made, but I guess a little later after this slide is finished because of our time. And the last one, OrCAD Suite, is basically a design suite to make your little circuits, because you're going to be working mainly with drawing them on a piece of paper, and to simulate how they behave before you actually make it into a hardware, you'd want to have some sort of software that you can check your designs with. And so this basically simulates, it basically helps you design the whole PCB, where then once you, a printed circuit board, PCB means printed circuit board, and then you just send it off to some manufacturers and they make this little neat board for you, and you've got, basically, since you designed it, you know what specific functions it's got to do. So the second one, computer engineers, they fall in the same categories, electrical engineers, many of the same courses. Maybe if you want to do a double major in both of them, take 3 or 4 courses after taking your computer engineers, and you'd be in a double major with electrical engineering. They use the digital logics, the logic systems that you kind of design in electrical engineering, but because they share some of the courses, you'll also be designing in computer engineering courses. You'll learn how to make digital logic from abstract world and you turn it into microprocessor or microcontrollers. The difference between microprocessors and microcontrollers, basically they're just supposed to be computing devices. They're processing devices. But microprocessors sort of went, and I was going to show you a slide from EC 511, which said that microprocessors are basically gone to very high-speed computing, and they've got to low power usage. Whereas microcontrollers have become more heavy power usage because they're going to be controlling like really big motors and things. And microcontrollers are also working at lower speeds, because if you go that high speed, you're going to enter hazards if you're trying to transfer it into physical domain. When you're going microprocessors, you're working usually with software, so you don't have any of those hazards that you'd have if you were actually working with a physical device like a robot. And usually they'll be running low-level code, which is assembly. I think if you've taken computer science, you know that everything to a computer is a 1 and a 0. And then when you go a little higher than that, you get into machine assembler code, which are actually, you're going to go into linker codes, which are actually forget about that. And you get into lower level codes, which are assembly, and then from that you come up with higher level code, which is like any object-oriented code, Java, C, C++. So the software you're going to be using with computer engineers, you're also going to use active HDL, which is simulating digital logic. So you basically create your little RAM or your cache or your registers that you're going to save the memory to. And you're still going to use a little bit of OrCAD Suite, but it's very minimal. You're not going to use too much of OrCAD. You're probably going to make some chips that you're going to design with specific pins, but you're not going to work too much with it. ASH IDE and ASMs, there's lots of ASMs out there, which is basically assemblers that convert the assembly code into binary code that a computer can understand. And some of the hardware you'd be using would be EC447 uses MSP430, which is a microcontroller, which you can control robots with. You can control motors. You can control like RC cars and stuff like that. The development boards kind of encompass like the whole software idea. They give you lots of functionality, but they mainly use a part of the development board. They're kind of like easy microcontrollers, not specifically tailored to one personal individual use. They have many uses, but they're used to understand what you're going to be doing in computer engineering. Give me a sec. Okay, now computer science is a very, I'd say, it's a very common field to go in because you're going to be you're going to be creating applications that this is the first time you're actually going to go straight to a user, some commercial user basically. So you can send your, you can run your code, you can see it's working, and you can give it to other people and they'll use it too. And they're going to be using like C, Java, they're using the high level code. They don't exactly need to know what the computer is doing at a low level, although it does help, and some courses do. In CS 367 and 471 go into a little bit of assembler use, but you're not going to be working with it in detail. So what the software and hardware they use, they always have a lot of compilers for each of their languages. Each of the programming languages, they have some sort of compiler code. Virtual machines, they use these to test some sort of specific code. If it has some sort of, if it's gonna do something like close the computer, or if you're trying to run some sort of network environment where you're trying to get one computer to talk to another computer, virtual machines allow you to see all the computers. Like you could have many computers in one computer. You could have like a Linux system running. Of course, all this code that you want to make, or probably you'd make it in Windows, but you also want it to be transferable to Mac, transferable to a Linux environment, or you could even get virtual machines for iPhones. So if you're programming iPhone technology, programming with iPhone apps and that stuff, you're going to get those type of virtual machines. ASM, of course, you're also going to be using some assembly code, and hardware, you don't really use a lot of hardware. It's always been software. Your laptop would be your only hardware, but sometimes it's the ARC, which is a club here, the Applied Robotics Club, they use microcontrollers, and they're mainly CS people. I met them, they're almost all CS. There are some computer engineers there though. So then brings us to information technology, which is a very vast field, and they get everything from applying all the applications that were made in CS. They try to get networks working so the internet gets up and running, and supply services like the websites, they always store something in their carts or store some sort of information. And I guess and then security is a main part of IT, but of course you start off with bachelor level here in Mason, you're only going to get IT. You're going to probably take a concentration, we'll get to that later, concentrations in IT, and concentrations in almost every field. But so far, information technology would have probably the widest field there is, and it's not a very good major to go in because certification, sorry for the guys that are IT, but certifications are main. I've talked to people in the job fair, they're like, the certification stumps IT major, IT bachelor's degree anytime. The IT information technology, you're going to get to a lot of, because your field is so advanced paced, you're changing like in every 2 to 3 years, you're going to be using newer and new software. And probably you're going to also be using more in-depth software, so you're going to have to learn with the curve basically. So that's why certifications kind of get you up to that level. They prove to employers that you are actually doing the work. You're actually up to date with the system. No employer wants someone that's working 10 years in the past. So the software you're going to be using if you're doing web development, which is kind of like artistic at this point, after you get a little skilled with it, it becomes generated code, which is kind of like artistic. You're just trying to make a good enough web page that users can find simplicity in. And they're using a lot of scripting languages, PHP, HTML, XML, CSS, all of those things are scripting languages. Some Perl, some Ruby, but mostly scripting. There's